comments. I can see that the members are already joined in the meet. So thank you, sir. And before starting the meet, we have few more minutes. So we have few instructions to our participants to present in the meet. So I will give you the instructions one by one. First one, you please don't switch on your mic. Keep the mic off throughout the meet unless you are asked to say something or you are asked to switch on your mic. So please keep your mic off and please keep your camera also off. So please don't try to switch on your mic and camera. Please switch off your mic and camera. And as well as that, please don't share your screen. If you share the screen, it will be an interruption to the speaker to share the screen. So please don't try to do that. Please don't share your screen. And if you just lose your connection and if you are rejoining to the meet, you will be asked to click the join now button, not the present now button. So please keep it in mind. And please pin the presentation screen of our speaker. It will be very helpful to you to find his presentation. Please pin that screen. And once more, please switch off your camera and mic, and please don't share your screen. And our meeting will start on 3 o'clock. On 2:58, Sriram will join the meet. Student fellow Sriram will join to the meet, and he will give you more instructions and he will give an introduction about the program. So we can see 27 participants are now. So we expect more participants. And please, one more instruction is it's about the chat window. Please use the chat window for your questions and to ask your question, to type your questions, not for unnecessary conversations. We won't allow any other conversation in chat window. The chat window is for typing a question to the speaker and for giving the contact details of UL Space Club. That will be given by the UL Space Club coordinators. And you can only type your questions, not any unnecessary conversation will not be allowed. So please follow the instructions. Please switch off your camera and mic. Please don't share your screen. And please use the chat window usefully for the question answer questions. And your question will be selected from the chat window and it will be used for the question answer session. Our student coordinators will handle the question answer session of this program. So if time is there, you can ask the questions directly to the speaker. We'll make arrangements for that. Thanks to all participants for joining. And once more, please switch off your camera and mic, and please don't share your screen. And please use the chat window in a good method. No unnecessary conversations are allowed. So I would like to hand over to Sriram to give more instructions and to give an introduction about the program. And, once more,
okay, Varnata, am I audible?
Yes, Sriram, you are audible. You can speak now.
Okay, first of all, I would like to give you some important instructions which already given by Varnatan regarding to the webinar. Switch off your mics and cameras until you have to express something important to us, and till the organizers invite you to talk something. And most predominantly, even if you rejoin after leaving the meet, don't press the present screen button, because if you do so, there's a possibility of losing the presentation of the speaker temporarily. And we wish you to pin the presentation screen of the speaker by tapping it from the people list. So it will be easy for you to see the slides of our speaker. And the chat box is only for asking your questions for the Q&A session. And all kinds of discussions using chat box are strictly prohibited due to the decision made by webinar committee. Discussions can be done in our WhatsApp group called Cosmos. If you are interested in that, please direct message to Varnatan or Bharat. They will provide their numbers in the chat box soon. So that's all for now. That's the instructions I have. Varnata, can I move to the introduction, or We
Uh,
can wait 2 minutes.
so we can wait one more minute. I think it's now 2:59. I think so. We can wait one more minute. So please, we can repeat the instructions. Please keep your camera and mic switch off, and please don't share your screen. It's the most important point. And please use the chat window for useful conversation, not for an unnecessary conversations. I think Sriram Bharat has the result of last week space quiz. If we are not going to present the result of the last week's space quiz, it will be published on our Instagram and Facebook page as we planned. So please check our Instagram and Facebook page also. Most probably we will announce the result by today. I think Bharat have the result with him. So that's all for now. And Sriram, I think you can start giving the introduction. Now it's 41 participants are there, so you can start your introduction.
Okay, Vernata. Good afternoon to all of you. Thanks to Vernatan for providing the instructions. And the results of the previous webinar quiz will be there in our social media platforms like Instagram and Facebook. I cordially invite all the scientists, veterans, teachers, UL Space Club organizers, students, and all other participants to the 21st session of UL Space Club webinar series. We, the UL Space Club, is a foundation under the umbrella of Uralungal Labour Cooperative Society, stands for enriching and flourishing the scientific aptitude of students, especially in space field. Within the 3 years from starting, we conducted many great offline events that's before COVID. And from the beginning of this COVID pandemic era, we started this new venture, the webinar series, which is going extremely well for these past 6 months. Today, in the 21st session, we have Dr. Thamban Meloth as the lead speaker on the topic melting ice and climate changes, status and views from space. Even though I saw it only in channels like National Geographic and Safari, etc., the whitish polarized caps are always tremendous to watch. And climate emergency was the word of the year of Oxford in 2019. Emotional aspects of this issue was well addressed by students of our age like Greta Thunberg. But we need a clarity by knowing it scientifically, especially in this scenario. Our lead speaker, Thamban is the group director in Polar Sciences at National Center for Polar and Ocean Research. So it's our pleasure and privilege to have an experienced scientist in this area of topic. I gladly welcome you, sir.
Okay.
Today, we have another speciality because October 10, the date in which the signing of the treaty in 1967 on principles governing the activities of states in the exploration and peaceful uses of outer space, including moon and other celestial bodies, was done, and this date is the conclusion one of World Space Week, which starts from October 4. We conducted so many events in this week. You can see it from our YouTube channel named UL Space Club. Please check it out if anyone missed any of those great sessions. This will be the formal concluding webinar session of the World Space Week celebration by UL Space Club. I'm coming back to the today's introduction. We have Varnatan, Abhinandatan, and all other core team members here to give you the instructions when it's necessary. And moderator of the session, our all-in-all Shadil here to control the session, and he will give the information about our respected speaker. Our chief mentor, Ike Kutisa, the former HRD director of ISRO, is here with us as always. Jairam sir, the deputy director of ISRO, and the former deputy director of ISRO, and the whole webinar family, including the eminent scientists all over India, will be with us in this session too. UL Space Club student fellow, Master Bharat Srijit, will handle the Q&A session after the talk. Damodaran sir, the one who plays the major role in connecting us to UL, is here to express the vote of thanks after the session. Our streamer, another student fellow, Adil Krishna, is also ready. So all set, without further delay, I welcome the moderator, Shajil sir, to take over the session.
Thank you, Sriram. We have been sitting here for the past 21 weeks in the era of pandemic, and most of us are suffering from, and the society is suffering from this pandemic. But still, we, with the help of technology, we are enjoying the field of science with the presence of eminent science of India in various fields. And today, on this 21st week, we have Dr. Thamban Meloth to speak on melting ice and climatic changes, status and views from space. Because space is also included in these things, and application of space science is included because it is the end day of the World Space Week celebration. We started this celebration on 4th of this month, and now we end with this talk by our honorable guest, Dr. Thamban Meloth, on our hot topic, that is climatic change. We all are bothered about the changes happening in this globe, because we have to maintain this globe in a minimum temperature, otherwise we may not be able to live on this earth. And all the signals of global warming is from the south end of this globe, that is Antarctica. The Robert Hooke, he discovered this continent, the white continent. We are aware of this continent through a bird, the fauna there, that is penguin. We know only the penguin and the ice block there. That we don't have any more information about the south pole of this region. Today we have a scientist with us, and he is well engaged with this Antarctic mission of India, and he is part of a great institution in India, that is National Center for Polar and Ocean Research, that is in Goa. And the headquarters of that Goa is in the name of one more Portuguese person who landed on Calicut, that here from where we are starting this seminar, it was Vasco da Gama. The headquarters, this is also interesting thing for us, the headquarters of this NCPCR is also name is Vasco da Gama. And we have this eminent scientist. He is mastered from Cochin University of Science and Technology with first rank in 1993, and he was he took his doctoral degree from Marine Science, Goa University, and with conducting work at National Institute of Oceanography. And later he secured his post-doctoral degree from in the form of NPDF from Science and Engineering Research Board India project, and structural investigation of extracellular polymeric substances from Antarctic microbes. This still we know that he is interested in the life forms in the Antarctica, where it is very difficult for the survival of the traces of life. And he's so interested in Paleoclimatology and Cryosphere studies. These two terms are unfamiliar to our common students. And even this organization is also unfamiliar to them. By this webinar, we make these unfamiliar scientific things to these students, and they get interested from these, from the words and presentation of our scientists. And as all we know that the ice is melting, sea level is increasing, and we are observing what is happening there. And we all are cautious about these things, and we have to do something to maintain life on this earth for a long time. That's why they are engaged in paleoclimatology and cryosphere science. And is also engaged in one more thing, polar snow biogeochemistry. There is no compartmentalization of the science field. Biology is there, geography is there, chemistry is there, physics there, everything is included in this area. In his area is a master of all sciences, not a particular one. And today we have him with the help of his master and professor Dr. Gopinath from Kasaragod. He suggested this great scientist name to our organization, and we today, and that's because we have Dr. Thamban Meloth here. He's a scientist chef from this great organization of India that still remembers about the survival of life on this earth. And today we make a warm welcome to our chief guest, Dr. Thamban Meloth, to this platform. Along with that, welcome, sir. Along with that, we have Dr. Gobinath. Sir is from Kasargod, has joined here, and some more scientists already with us who are part of ISRO, and ISRO is supporting us a long time. And we welcome you all, and all the enthusiastic students and teachers are again welcome to this platform. And I invite our chief guest and scientist Thamban Meloth sir to deliver his wonderful talk on Antarctica. Welcome, sir.
Thank you. Shall I start now?
Yes, sir. Yes, sir.
Okay, good afternoon to all of you. And first of all, good afternoon and thanks to the US Space Club. Thanks to Shajil UK for inviting me. And more importantly, thanks to Professor V. Gobinathan, who was my guru and who was my teacher and also was my colleague for some time, for making me to be part of this wonderful, I would say it's a very wonderful group of youngsters, enthusiastic youngsters, wants to know about space, science, and everything below that. Also, thanks to many of these ISRO scientists as well as seniors for being part of this. Thanks to Kuti sir again for helping me to be over here. First and foremost, let me go with my presentation and then we will talk more. Are you able to see my slide?
Yes, sir. It's very clear. Melting ice and changing climate. Okay.
Right. Thank you so much once again. I was really surprised actually what space club would be interested in something like maybe a climate or even something related to polar regions, which is absolutely not exactly what is something a space scientist would be looking at it. But ultimately, space science or the space technology is used for understanding our Earth system. Our Earth system has various components. Among that, the ice, or what we call as a cryosphere, is just one of the components. So space techniques and tools are extremely important as well as very well used for understanding the changes happening on the region where there is ice. So today's my talk is called, I just titled as Melting Ice and Changing Climate. I'll try to give a status as well as what are the kind of things what we learn from the space. As I've been already introduced, I belong to the National Center for Polar and Ocean Research. This institute is situated in Goa and it's under the Ministry of Earth Sciences. Ministry of Earth Science have various sister components, almost 10 in other institutions across the country, and we are handling the polar science. I would like to keep my because there are a lot of youngsters, so I just want to streamline my talk in such a way that most of you are able to follow what I'm trying to talk. I'll try to explain first of all what exactly is the cryosphere, what it looked like, why we study cryosphere, and where it exists. Then I'll try to give an importance of the ice sheets and glaciers on this global system. Then I'll try to explain the three components of the cryosphere and three components of the polar regions called Antarctica, which is a frozen continent of extremes, Arctic, which is again a frozen ocean, and the Himalayas, or what we call as the third pole, and the water tower of Asia. I'll try to give a glimpse of how do cryosphere play a role in climate system and climate change. And then I will try to talk about the response or the impact of the climate change on the glaciers and ice sheets. I will also try to, in fact, throughout my talk, you would see a lot of the kind of the pictures or the videos what I'm showing will be basically are obtained through the space techniques, because there's no other one technology which has been so much useful to across the globe, able to look at the much larger picture of the globe, what is happening, because none of us are able to do it ourselves, going personally and doing every kind of research. So the science is immensely helped by the satellite techniques, especially satellite remote sensing for most of the natural sciences. And I will also try to give a glimpse of what India does in the polar regions and especially in the cryosphere. If you look at Earth system, many of you are young students actually, you must have heard geology, must have heard earth science. So Earth behaves as a system. In the past, we used to think these compartmentalized systems like, geology is separate, atmosphere is separate, lithosphere and hydrosphere and biosphere. All these were supposed to be compartmentalized. No longer such silos are existing because we understand the globe functions as one system, and within that, geosphere and biosphere interact with each other. There are at least about 5 spheres which are completely interlinked as well as immensely important for the human mankind. To start with, the atmosphere, where we breathe our air as well as provides a life for us. Then the hydrosphere, which covers nearly about 70% of the Earth's surface, covered with water like the oceans, lakes, and rivers, and wetlands, and whatnot. Then you have the lithosphere, which is what you see on the surface of the Earth, actually, the rocks and soils and all other material. Then you have this biosphere, where all the life exists. In fact, the biosphere exists in all of these things, including atmosphere, hydrosphere, lithosphere, and cryosphere. Then there is one of the sphere which you must have very less heard, or many of them may not have never heard, is called cryosphere. Cryosphere is that part of the Earth's surface where the Earth is in, or the water is in frozen form. So the cryosphere includes snow cover, glaciers, ice caps, ice sheets, sea ice, and frozen ground. If you look at the entire cryosphere globally, Antarctica constitutes about nearly 91% of it, because it's a huge land covered completely with ice, and also has ice which is very thick, sometimes as thick as 4 kilometers. Therefore, the Antarctic ice sheet is an extremely important component of the Earth system and the dominant component of the cryosphere. Then we have Arctic. In the Arctic, the land which is actually the ice which is frozen is we find only in Greenland mostly. Then you have the sea ice frozen, what we call the Arctic Ocean is completely frozen. Then you have the mountain glaciers. Most of the glaciers which you find in the high mountains of Asia, like Himalayas, Andes, and in the Rocky Mountains, even in the Americas, and also on. All these are constitute actually 1% of the cryosphere. However, what you should also keep in mind, since mountain glaciers are extremely close to where the humans live, they form the lifeline of a large number of large percentage of the human population. So this 1% of glaciers has this extremely high importance when we discuss about the life and its existence is concerned. However, what is one thing which is very common among all these is that remoteness. Reaching any of these cryospheric regions is an extremely serious task. So, and that's a hugely challenged because of our inability to reach there, or the difficulties to reach there, the ruggedness of the places like mountains, or the rugged or the harsh conditions of these polar regions and so on. Therefore, unlike any other Earth system science spheres, cryosphere is one of the least known, simply because of that. So within the polar regions, the two major poles, or basically what we call as the poles, Antarctica in the southern hemisphere, or what we call around south pole, which is Antarctica is a land surrounded by the ocean. And if you look at the southern hemisphere itself, we call it actually as a water hemisphere, because other than Antarctica, it's a large amount of the ocean surrounding it. So we typically call it as a water hemisphere, because 91% is covered by water other than Antarctica and part of these 3 continents, like South America, Africa, as well as Australia. Coming to the north, around the North Pole, we have this ocean. Basically, North Pole is in the ocean, whereas South Pole is in the land, which is Antarctica. The North Pole is essentially the ice or the water, the sea water is in frozen form. And also there is a land, which is basically, you have this, Greenland, what we call it, which is again frozen. Then you have the large amount of this small, the Canada, Alaska, which is part of the USA. Then you have this entire Scandinavian, the Russian, Siberian Russian, as well as the Scandinavian countries, which are basically part of the Arctic region. So Arctic is essentially an ocean surrounded by land, whereas Antarctica is a continent surrounded by ocean. That's something you have to keep in mind. Then there is a third pole. The name, what we call as third pole, is a recent, or it's been to existence only about the last 10 years or so. Before that, it was never called as a pole. We call it as a third pole again because it consists of one of the only area where the ice found is a very high form or high quantity other than the two poles, and it also forms the source of water for the major rivers, the 10 major rivers around the world, and therefore they provide the water as a source for the entire the Asian as well as other regions. Then it also has the largest peaks, more than 8,000 meters, is also found in this particular region. So it's also known as third pole. If you look at the, if you want to understand the importance of the cryosphere, you should try to understand what is happening to the globe. As you would be knowing, the global temperature is been, global warming is a very common terminology. And it's no longer a fancy word which used to be, about 20 years back. When 20 years back, when people are talking about global warming, people say, yes, okay, then, but it's still, they never thought it's going to reach to them. But if you look at now, every year, the simplest case example is of, our own state, Kerala. You will be seeing every year we are suffering from one or other problems. If it is floods during the monsoon, it could be heat waves during the summer. Heat wave was never heard of it, several years back. Now that becomes so common terminology in Kerala, and across India it's become very important, this one. So the global temperature has been systematically increasing since the last several decades. If you look at this is one of the global temperature data, including that from the land and ocean. What I find, there's been a systematic increase, especially since the last, since the industrialization, since 1980s or 70s. Thereafter, there has been never something going down. There would be, its annual variabilities. There could be seasonal changes, but the trend has been always increasing. So this is something which has its own repercussions. That what we see actually at the moment in the globe, extremes. The climate extremes are the direct result of what is happening to the globe at the moment. The global warming and changing climate is the reason for what we find as extreme climate. Could be extreme precipitation, extreme wind, it could be extreme heat, or it could be extreme snowfall, and so on. So one of the most important and very interesting aspect of global warming, which you are not directly seeing it, but we see in the polar regions, is that what we call as a polar amplification. Polar amplification is nothing but whatever the globe warming which you find in the globe is amplified, especially in the poles. If you look at this particular map, which shows a red color, is essentially shows the temperature, which is very red color means increased temperature compared to this yellowish areas. And if you look at the variability you find across the Arctic region, you have an extreme high increase in temperature. That is the temperature. If globally the temperature last 50 years was about less than 1 degree Celsius increase, in the polar regions it's about 2 degrees Celsius. So it's been almost double of that what you find typically in other parts of the globe. The reason for the polar amplifications are many. One most important thing is the albedo feedback, we call it. Albedo is nothing but the reflectivity of the Earth's surface. The ocean, which is a blue in color, is actually about 80% of the solar radiation is absorbed, whereas compared to that of the white surface, which is snow or ice, it's 90% of it is reflected back. This imbalance is what actually really create the global climate system. So as the ice is melting, there is some there are small patches of this blue areas forms, and that becomes absorb more and more radiation, leading to the expansion of this the blue areas or the water more melting. So it's a continuous feedback chain. So as a result, what you find, especially in the Arctic region, is that actually there is systematic increase in the the temperature. It's also true that that's only one factor. There are many other factors because of this changing climate system. There is the systems between the tropics and polar things are changing. Therefore, you find this amplification happening. So that's what actually, if you look at the across the the latitude, there's one picture here actually. If you look at the temperature change across the latitude, the northern hemisphere is extremely high compared to that of the tropics and temperate regions. And then it's higher again, closer to Antarctica. But Antarctica is not as warm as Arctic yet, but it's just the beginning at the moment. So, many of you must be thinking actually, when you sit, somewhere in a place like our tropical regions, like in India, we are not really so much worried about ice sheets and glaciers. So, what are their importance? How really do they make a difference? You would be surprised. They have a huge impact on the society, globally, regionally, as well as even locally. We look at the global terms, the cryosphere or the regions which has ice sheet and glaciers have a significant impact on the global sea level rise. For example, Antarctic ice, which I said I would be discussing further in the coming slides. If the entire Antarctic ice get melted away, you can increase the sea level by nearly 60 meters, 60. That is an extremely high sea level rise, and that could also impact the entire globe, because even with an increase of the proposed 1 meter increase actually in the coming century itself, we know that most of our cities or the coastal cities are vulnerable. They are already close to the sea level. So sea level rise is a very significant and serious issue as far as the ice sheets and glaciers are concerned. Secondly, as I told, actually, the cryosphere or the ice sheets or ice cover significantly alter the Earth's energy balance. How? As I told again, it's the cryosphere or the ice sheet is a white surface, and it's nearly completely reflect back the solar radiation. Therefore, the region becomes cool compared to that other areas, the land areas or ocean area, which get warm because it takes the temperature. So this imbalance is essentially create the global energy balance system, which in fact ultimately lead to the climate system. Thirdly, the entire global ocean circulation, as some of you would be knowing, the ocean covers nearly about 70 to 73% of the Earth's surface, and ocean decides climate systems. Like, for example, our monsoons. The monsoon climate system is directly related to the kind of the moisture availability, as well as the oceanic circulation systems. What you find are directly related, influences the monsoon systems. You would be hearing every year actually El Nino. It's the impact of the oceanic circulations like El Nino Southern Oscillation, Indian Ocean Dipole, and so many other such factors which are deciding how much rainfall we get it, or how much rainfall whether we will get a drought or not. And the oceanic circulation, which provides a large scale circulation, also decides the kind of whether the region remains warm or cold. So it has these three are major global issues. We could look at regionally, the many parts of the world, especially where the population is very high, like for example, simple case of India or the northern India or the China or the many of those countries surrounding this Himalayas and so on, the water dependence about the glaciers are very high, because many of the glaciers provides water especially during the summer season, when there is a water availability is extremely low. So the glaciers provide the main source of water for drinking as well as even for the agriculture. So the dependency on regionally is very high for glaciers. And it also influences or in fact have a very high impact on the energy utilization. You must be knowing actually most of the the large dams with what you call hydroelectricity power systems within India or China or most of these big countries are depending on hydroelectricity, which is basically by making these big dams across large rivers. So therefore, they directly influence the energy availability. They also impact the agriculture, which is no wonder, because the rice bowl or the wheat bowl of the North India or the other countries are depending on the water availability of major rivers like Indus, Brahmaputra, as well as Ganges. and therefore they have a very serious impact on the economy. If you look at locally the glaciers and ice sheets have a tremendous influence on the tourism, because most of us are very interested to go to places where there is ice or snow. And again, it depends on the local agriculture. I mean to say, actually, like this horticultures, like fruits and other things, are highly dependent on this year-to-year snowfall variability. And thirdly, local hazards like avalanches. You find very commonly when you go to Himalayas. If anyone of you gone, you must have seen actually how hazardous regions do exist in Himalayas. Mostly, also because of the the snow avalanches takes place, or the immediately after the snowfall or called winter gets over during the springtime. Because of the ice start melting, these hilly regions become unstable and they lead to a lot of hazards. So it's important to also study these regions for hazard purpose. Why are the polar regions itself is important? As I already told, actually they are important in many ways, but I just wanted to put them in again in one sheet. Just to say that the Earth system processes are controlled by the polar regions. The climate change impacts are most dramatic at poles, as I told in one of the slides, that it's get more warmer and heated up at the poles. Therefore, they are the most vulnerable parts of the Earth system. And they also are home to amazing biodiversity and life adaptations. You must have already heard some of these birds and this, animals which you find only in the polar regions. But more importantly, there are so much of lower level life in the life forms like microbials, microbes, virus, and everything are so much diverse in cold regions. And they also have an extreme conditions and also have pristine environment which you cannot find anywhere else, and therefore it's got a fragile ecosystem. Most importantly, more than 80% of the Earth's fresh water is locked in ice. If you want to look at the future of Earth's freshwater requirement, could be coming from this ice. That's not a surprise. Therefore, actually, people are really studying in a much bigger way. And finally, they're economically so vital for the future of mankind, especially the region in the Arctic, because as the ice is melting, the Arctic Ocean is available for people to explore for hydrocarbons and fisheries, which is at the moment is not existing much. They started already. In fact, already ice is melting. Therefore, already explorations have started, and it's going to be much higher. So now we discuss each of these three regions separately. Let's start with Antarctica. As I already mentioned, Antarctica is a remote and frozen continent of extremes. Look at the size of Antarctica. It's a huge continent, which is about more than 2 times of United States of America and nearly 4 times of that of Indian subcontinent. So you can imagine what such a big, India itself is such a big country. You know that, and then if you can imagine, actually Antarctica is about more than 4 to 4.5 times of India. It's such a huge continent, and it's also one of the coldest parts of the Earth's surface, where the temperatures as low as minus 90 degrees has been already reported. But it's been told that there are also places in Antarctica where there is even lower temperature exists because it could not be monitored because there is no station or other such places existing in such cold places. At least the satellite-based studies suggest that there could be a temperature as low as minus 100 degrees Celsius. That is really cold. And compared to any other continents across the globe, Antarctica is the highest of that, because it got an average elevation about 2,500 meters. Mainly because Antarctica is a continent like any other continent. On top of that, because its temperature is so low, we have frozen ice as thick as 4 kilometers in some places. So altogether, the elevation of Antarctica is much higher than any other continent. And it's also one of the windiest places on Earth, where there could be winds as fast or furious as about 300 kilometers per hour. Typically we call them as blizzards. They're very common in Antarctica. Antarctica is a polar desert. It's one of the driest places on Earth, where average precipitation is less than 2 inches per year. So there is no moisture available. So whatever the precipitation, what you call snow you find, they have been formed over millions of years as very fine small particles and as well as moisture from the ocean. So they have extremely low precipitation itself. And it's of course it's the iciest place on Earth. As I said, ice can reach as deep as 4.8 kilometers at some places. If you look at Antarctica from space, it just looks like a piece of marble. This is actually a picture from space again. It looks simply a white piece of marble with no interest, nothing much interesting in space except some of the small mountains. But using various satellite technologies, several satellites continuously start looking at Antarctica. What you can find is a beautiful piece of art. Although it's actually part of the science which they are done, you can see beautiful, this dendritic patterns which is happening on Antarctica. Essentially nothing but it's a moving ice. It's essentially, ice flow, chartered from space. NASA used various available satellites from the Canadian Space Agency, the two satellites from Canadian Space Agency, CSA, then European Space Agency's, satellites, two satellites, again, Japan, Texas, another satellite, and therefore, with the multiple satellite, the advantage actually is that you can continuously keep looking at one place. You will be able to find the variations happening to what happened to the ice. Ultimately, you will be able to monitor the change in the ice flow. So what you find here, what you call the purple or reddish color are where ice is moving very fast. You see the below, legend which shows it's as about 1 kilometer, even some places as fast as 3 kilometers per year. That's the speed at which ice can move in some places. Whereas there are places in Antarctica, especially Antarctic plateaus, where absolutely no movement exists. You can see the brownish color. It's a very absolutely standstill. So ultimately, they all form something like a river system, what you find on, or say, for example, in India. The only difference is that actually ice behaves like a, for a students, I just like to put this in example. Ice behaves like something like a tomato ketchup. Tomato ketchup, behaves partly like solid, but partly like water. If you keep on pouring a ketchup on the top of your table, after some time it starts flowing down. So you know it for sure. Whereas if you put one single drop, it may look like, oh, it can stay where it is. But as the amount of that ketchup increases, it needs to flow because that's a viscous medium. Exactly on a similar terms, ice is something like that. As the ice thickness keep increasing, it needs to find a mechanism to reduce that stress. So it start moving to places where there is less the ocean. So the surrounding areas are having the ocean. So ultimately this ice start trying to reach to the ocean. Okay, so if you look at Antarctic climate, as I told, it's a cold desert. When I say cold, I'm talking about temperature. If you look at the picture on the left side, you find temperatures varying from minus, as I told, actually temperatures can be as cold as minus 100 to as warm as temperature about 0 degree in some places. Typically, the coastal Antarctica are warmer, about temperature about minus 15 to minus 20. Interior Antarctica, which is also the highest part of the Antarctica, with a higher elevation, are also the coldest part of Antarctica. And there are some places which are very cold. And there are also places like very few spots in Antarctic Peninsula. If you look at Antarctica, this is what we call as East Antarctica. This is what we call as West Antarctica. There is a trans-Antarctic mountain running across this, and this Antarctic Peninsula. Antarctic Peninsula being closer to the other continent like South America, we find that it's it's much more warm. So it's a cold place. Secondly, as I told, it's a desert. When I said desert, the precipitation is as low as absolutely zero at large part of Antarctica. You can see here. Entire thing is a red spot here. You can see about almost 0 meters per annum. And it can be as high as about 2 meters per annum in the Antarctic Peninsula because, as I told, it's close to the ocean, a lot of moisture available. So closer to the boundaries or the coast, you find higher precipitation excess because this region has, the ocean is warmer and provides moisture and therefore you have more precipitation taking place along the coast. Whereas interior Antarctica, which is colder as well as higher elevation, does not have any precipitation at all. If you look at Antarctic ice sheet elevation and topography, again, I just want to give this example, this picture, because most of us, you would be thinking Antarctica is just an ice-covered place. But you should understand, Antarctica is just like any other land, like Indian subcontinent. As you may, some of you may have heard, India was part of Antarctica long back as part of the Gondwana system. So the rock and the land which you find, you have all kind of valleys and the mountains existing in Antarctica. However, the entire thing is covered by ice. So in East Antarctica, the thickness can be as thick as about 3 kilometers, and in West Antarctica, it's much less, about 1 kilometer thickness. So if you go from West Antarctica to East Antarctica, what you find, relatively higher elevation in the West Antarctica. Then you are going through the floating ice shelf, what we call as the ice shelf. Ice shelf is nothing but the ice which floats over the ocean, which is formed by the ice supplied by these areas. When a lot of ice falls here, it finally starts moving here, so the ice shelf forms. Then you have the East Antarctica, which is very cold and large thickness of ice. I hope you can hear this.
There is no sound, sir.
Okay, I understand. Sorry. So that means I need to talk. So basically, it's is the international project which is looking after how to measure the thickness of this ice using various satellite, as well as essentially because of the radar techniques trying to measure the thickness of this ice. Even Indian Institute also part of this particular project. So essentially, what we find, the thickness of this ice is exactly what you find anywhere rest of the other continents. Yeah. Okay, I was under the impression actually the sound could be heard, so that means you're not hearing it. It's fine. So now I just want to give this one more picture here, basically just to give a schematic diagram what it looked like in Antarctica. As the ice starts forming, you have such thickness of ice sheet forms, and because of this, the pressure, such a large amount of ice start flowing from this the middle, where there is absolutely less pressure to compare, then it start flowing towards to the ocean. So then ultimately this ice start becoming ice shelf floating into the ocean, and they start breaking away and forming icebergs. And this is what actually ultimately a typical Antarctic look like in a simplified forms. What is the role of Antarctica in a global climate system? As we already mentioned, ice covers most of Antarctic surface, which is highly reflecting, thus cooling the atmosphere through albedo effect. Thus, Antarctica acts as a global thermostat. This picture tells you the solar radiation, which is the main energy for the Earth. Almost 80% of the solar radiation falling over the Antarctic surface is get reflected back. Whereas the same thing when it falls over the ocean surrounding it, get absorbed. So any amount of the larger the land or the white surface, you will be larger reflection. That means as Antarctica, I'll coming back to the next video. That time I'll show that this particular ice coverage start changing through seasons. This is a typical thing what you see during summertime. The summer, when I'm talking about the summer of southern hemisphere, that is during December, January, and February, when we have winter here. And that time it is this is typically how it looked like. But as it goes to winter of southern hemisphere, this size nearly doubles. That next slide will show that. So therefore, Antarctica is surrounded by a large extent of sea ice, through freezing of the surface ocean layer during winter, making the ice cover nearly doubling and increasing the albedo effect. This movie tells you, again using satellite data, it's like it's like your heart pumping continuously. You can keep changing the shape and size of Antarctica because of the sea ice. This entire thing is sea ice. During the peak winter, it's quite high. Then they start decreasing as October. All these are actually as the summer is coming up by December. You can see that almost entire sea ice get lost. And as again, we become nearly very little, and then again it start increasing as the month of March, which is again the coming of fall. So therefore, this particular change also decides how much sunlight can be absorbed or reflected back. That's why we call it as a global thermostat. And Antarctica also has another role, because as sea ice forms, seawater is rich in salt content. The salt is forced out of the what I call ice crystals, because ice lattice cannot hold a foreign particle like sea salt. Therefore, it get ejected, and thus forms a brine. Brine is nothing but actually very saline water. Because it's very saline, becomes highly saline after some time. Then it starts sinking to the bottom of the ocean because it's very heavier in nature. And there's such a large amount of salt rejection and very dense water formation, circulation starts. What we call as the global Thermo-Island circulation. This is one of the largest global circulation in the world, and it travels across the globe. You must have studied in your geography classes that the Gulf Stream, which provides the warmth to the European, which is a blanket of the Europe, we call it, because it's essentially because these kind of circulations. There's a warm water which goes around across to up to the Arctic. Then because it gets cold, sea ice start forming. You have the brine ejection takes place. It starts sinking, become again cold, comes down again. It starts moving over other oceans and so on. This is a very, very large scale circulation happens across the globe, and has a huge importance how our ocean controls the global circulation. And Antarctic coast is one of this key site for such deep water formation. And if you look at Antarctica's role of sea level, as I told, it can be very high. And if you look at the data available, recent data available from since 90s till 2016, there's a significant increase in sea level contribution from Antarctica, especially because of the ice start melting large scale in the West Antarctica. Otherwise, typically the East Antarctica is mostly still remain cold and it's not affected so much. Now we go to the Arctic. As I told, actually around the North Pole, the water gets frozen, and basically it's nothing but sea ice compared to Antarctica, which was a land ice. So whenever you hear about poles are melting, don't get confused. Arctic is essentially more of sea ice, and they are more vulnerable for melting, because not only from the atmosphere is getting warmer, but also ocean is getting warmer. Since it's a floating ice, the water surrounding it, which is basically eroding from the bottom, makes this ice much more vulnerable compared to that of Antarctic ice. Therefore, Arctic is much more getting in a problem because of the warmth. The Arctic, consists of large areas of Arctic Ocean, the Greenland, which belongs to Denmark, and parts of Alaska, which is part of US, Canada, Finland, Iceland, Norway, and so on. And it has a seasonal variability again. The sea ice, because it's sea ice, it changes through seasons. Because during winter time it will expand, and summertime it will be lesser. But unlike Antarctica, Antarctica has only seasonal sea ice. Trying to again explain to you, Antarctica is land covered with a thick ice. Also surround and along the coast, you have the sea ice formation during the winter time. However, in Arctic, the sea ice is much more thicker. We call multi-year ice. Multi-year ice means year after year, because there's so much of cold, it gets formed thick ice, and they don't easily go away in the summertime. But there is also the seasonal sea ice surrounding it, which goes during the summertime, but winter time it comes back. So there are slight difference between Arctic and Antarctic. So one thing which we have seen throughout the years, if you look at the the median sea ice extent since 1981 to 2010, it was covered almost entire Arctic Ocean. It was covering. Now it has reached to this level. So this region, entire region, is becoming now the ships are able to travel, which was not possible some years back. So the melting sea ice is completely changing the environment of this region, also the geopolitics of the region. When I say geopolitics, because these are strategically extremely important areas because of the currently you must be knowing the entire the shipping routes happens through the Suez Canal and comes to the Indian Ocean, then travels across to places like Japan, China, and all that. This will completely change if this route get opened up. It can go north of Russia, Siberian Russia, and then travel through this, between the US and Russia, and then it can reach to places like Japan, China, and so on. So there is a huge strategic importance for what's happening to the sea ice. Of course, it's environmentally, it's a tragedy. It's going to be seriously affecting many things, but there are also large economic importance to it. So Antarctica and Arctica, since I already told this many times, I'm not explaining here more. These are two completely different sort of places. Antarctica being in the south, actually is a continent surrounded by ocean. Arctic is an ocean surrounded by land. Geographically, it's different. It's in terms of climate, it is different. Antarctica is much more colder compared to that of Arctic. And the life in Antarctica is slightly different than from Arctic because Antarctica absolutely has no trees or shrubs or any flowering plants. And compared to that of the Arctic, which has a well-developed tundra, which is small trees and shrubs are found typically in Arctic, and because it's much more warmer also. And more interestingly, Arctic has its own indigenous human inhabitants, what we call Inuits, compared to that Antarctica, which has absolutely no native land animals. Now we reach to the third pole. The third pole is nothing but the region of what we call the Hindu Kush Himalayan region, which consists across the Hindu Kush region, then this Himalaya, then this Tibetan region. So except the Karakoram, Karakoram is over here. So this entire region is now known as the third pole because it's this, what I call dark green colored places for the glaciers exist. However, there's a large areas of permafrost. Permafrost is nothing but land permanently frozen, which has a large significance because it holds a lot of water. As the region becomes warmer, there will be water coming out of the land itself, quite a large amount of water. So this is known as the third pole. I'll come to the important. When you look at the importance of this Hindu Kush Himalaya, you will be really surprised how important it could be. Nearly 250 million people depend directly on this Himalayan region for their lives and livelihoods. But if you look at its direct and indirect dependency, nearly 2 billion people depend on this region for water, food, and its energy. And more than 35% of the world's population benefits indirectly from its resources and ecosystem services. Because the two largest countries, or many of the largest countries, most populated place exist in this particular part of the world. And it has a huge, several biodiversity hotspots, and it has the largest reserves of ice around outside the polar regions. It is source of 10 major river systems, and it's been a cradle of many civilizations. If you must have studied your social studies and others, geography and so on. So empty number of religions initiated from this particular region, and the traditional knowledge systems in this region is much diverse and much bigger than any other part of the world. So, therefore, it is critical for life, economy, and energy needs of Asia. This particular picture tells some of the river basins, like for example, Ganges or Ganga River Basin, nearly provides needs of about 600 million people, something similar to that what Yangtze, which is in China, and much bigger than Indus River, and so on. And more importantly, or more interestingly, you would be surprised to know that our major energy resource, for example, China about 370 gigawatt power, is about 370,000 megawatt hydropower potential, which they almost utilize about 86%. Compared to that, India is utilized only less than 30% of our actual potential. So there is a huge amount of potential of hydroelectricity from production in many of these countries still. Therefore, they can be highly important for energy requirements of the Asia. Now we come to the second part of my talk, which I'm trying to talk about impact of climate change on poles and how do space observations help us to do that. As I told, actually the Antarctica is melting, Arctic is melting. There are a lot of life get threatened by that. Like in polar bear in Arctic, it is a typical picture you would see anytime when something discussed about Arctic ice is melting. This polar bear typically lives on large seals and such kind of mammals, but that means they require a thick ice because they make they do the prey they find in a small holes of that. But when the ice become very less thin, these polar bear, they are so heavy, very 3 times of that our weight. They are so heavy they start falling down. They cannot easily do hunting. Same with penguins. Penguins requires actually the food around Antarctica. So as it gets warmer, you don't have some of this small krills which they depend on food. So it's going to be a problem for most of these organisms living there. Now, what does it mean to the Antarctic temperature? If you look at the temperature variability which is happening in Antarctica, this has been possible again only ever since space exploration started. So therefore, almost all available data for Antarctica and the Arctic region essentially starts from 1980s, because most of the space data start coming from 1979, or since 1980s we have a larger number of space data. So most of such available information, this is again used of space-based sensors like infrared and other sensors which measures actually the temperature variability on the Earth's surface, and it finds that through this time they find that temperature on the West Antarctica is increasing, and there are several hotspots across this region, especially in the coastal regions. If you look at the effect of that warming, what people find is that there are 2 types of things happening for Antarctica. One is that because of the radiation on the surface of the ice, there's a surface melt takes place. Then, because the ocean is getting warmer much more, because ocean is a black body compared to that of the snow or ice, therefore it gets warmer faster than the ice, and therefore this warm water will start getting close to the coast of this Antarctica, especially below the floating ice, things like ice shelves, they start eroding from the bottom, so leading to the what we call as a basal melt. So it's not only just loss of ice happening due to surface melt, but also due to the bottom melt, or what we call basal melt. This tells you actually, essentially, this is used by another space technology called GRACE. GRACE satellites are essentially 2 satellites traveling, almost same time with same kind of observations, so gravity observations. Just looks at the minute variability of the gravity changes happening on the Earth's surface. These gravity changes could happen because of changes in the glacier change or the decrease in ice. It could be due to the decrease in groundwater, decrease in the water on the surface. Due to many reasons, gravity change can take place. So ultimately, what we can find in a place like Antarctica, which is completely covered by ice, most of the changes are due to the melting of ice or the loss of ice. In places like India, again, this gravity changes could be due to the loss of groundwater, because due to the GRACE observations, they have found that regions in the northwest India, in fact, actually has been losing a lot of groundwater because of the heavy pumping which is happening, especially in Punjab and Haryana and so on. So these kind of observations are really useful not only for our own country, but even to understand how ice is being lost on this Antarctica. So we find there's a systematic decrease of ice happening since 2000, when the GRACE observation started, and it ended in 2016. So there is a GRACE follow on another satellite, 2 satellites again going to start now. So they will provide you the information starting from here now. So you will have a continuous follow-up on this. It provides one of the best available data on Earth's surface, actually what changes happen to the ice, what changes happen to our land, and what changes are happening to our rivers and so on. So far, within this less than 15 years, they found that nearly 125 gigatons of ice being lost per year. A gigaton is nothing but about 10 to the power of 12 kilogram or 10 to the power of 9 tons. So it's a huge amount of ice being lost, essentially happening around the West Antarctica. I will come back to this again. Therefore, a latest publication which clearly shows that there is a large regional difference of ice loss in Antarctica. The large part of Antarctica, which is in blue in color, there's absolutely either ice is increasing or there is no change. Whereas there is a significant part of Antarctica in West Antarctica, as well as across the coastal part of the Antarctica, they are losing ice as much as about 10 meters per year is being lost many of these areas. So this was again possible because of the satellite data. If not for that, NASA's that ISAT satellite and as well as ISAT-2, there are two, one took a measurement for a certain year, and then we have started another satellite which provides actually the changes happening through time. So these are the wonderful possibilities of using space to find the changes in ice. In the next video, tell you a little more picture, but it's a movie, but I will try to explain it. So, are you able to hear now?
No, sir.
Okay.
I think some adults. Okay.
Right. So basically, they have used two types of satellite, actually ISAT as well as ISAT-2, and they provide actually the changes what's happened to the Antarctic surface. They continuously took this polar orbiting satellites using laser altimetry. Laser altimetry provides a very high resolution changes on the surface of the Earth, in this case surface of the glacier, and they provide the high changes through time. And if you have two different satellites happening to different time, and if they are able to cross the, so if they are able to continuously, are you able to hear now?
We can hear you only, sir.
Okay, that's fine. That's fine. So that's fine. So what they find actually ultimately, they were able to find this large variability happen through this nearly 2 decades, essentially because of the underneath from the ocean bottom, ice is being melted away and making the ice vulnerable to the loss, and from the top, because ice is flowing as well as melting, there is a continuous flow towards the ocean. And in Greenland, again, they basically find, there is a large changes happening around the boundaries of Greenland. And again, this was made possible because of the two very precious satellite data. So what we are finding is a very interesting area of understanding that in the future, it's going to be much more vulnerable as actually there's a continuous warming takes place. And what we want to know, say, how exactly this process takes place. Are they going to be, stable in the coming decades or coming centuries, or there could be a dramatic change? It will ultimately will be lost completely. So that is something which we still do not know at the moment. But what we know this ice, in a coming 1 century, it is proposed or the simulated and suggested that about nearly 1 meter of ice or the water sea level can increase because of melting of sea ice. That means large parts of the coastal regions could be impacted by that. Of course, many of us will not live to see that, but then we are already seeing it. If you look at many parts of the coastal regions, there is a slow carving of this land taking place. This is because this does not happen in one fine morning. It happens through decades and centuries. So to augment this, basically now NASA and ISRO is coming together because what they call as a NISAR mission, which is basically NASA, ISRO, SAR interferometry observations. They will have a satellite mission exclusively to look at the very minute changes on Earth's surface. So it will have a 12-day regularly continuous and ascending and descending process. They will continuously sample the Earth on average about every 6 days for at least for 3 years. In fact, the NASA mission requires about 3-year mission, and whereas the Indian mission would require about 5 years. What they would be using is actually interferometric synthetic aperture radar measurements, what we call INSAR technique, which provides a very high, what I call, it's a recent technique actually using, the satellite information, different set of, synthetic aperture radars. Actually, they are able to identify the very minute variability in the, the phases of changes that's happening because of the, changes on the surface of the Earth. So they would be using two, major sensors called L-band radar, which is about 24 centimeter wavelength, and the S-band radar, which is about 12 centimeter wavelength. Both polarimetric sensors, and they can have a resolution about 3 to 10 meter. You can imagine the kind of wonders it can do. Such a high resolution, about 3 meter resolution using a space technique is extremely, we used to only think it's in the past as a dream. That's going to be possible with this particular mission. And the planned launch date is going to be in 2022. We hope it happens, although we are under problem related to COVID and other delays. But hopefully, this is going to be a huge important especially for Antarctica, because this mission, especially from the Indian side, actually are going to focus on the Southern Ocean and Antarctica. Whereas the L-band radar basically will be looking at the entire larger Earth surface, whereas the S-band is specifically going to look at that particular region. So they will have very high resolution measurements. So this is something actually will make a difference to the how we understand the Earth surface changes. Now come to the Arctic. As I already mentioned many times, Arctic ice cover is decreasing alarmingly. You almost hear every day newspaper and in your online medias and so on. What we find actually is that the retreat of Arctic sea ice, if you look at from the space again, so it changes through time, it changes through seasons, but it changes through year after year. And what we find when we started from 1980s, when the first satellite measurements took place, to what we find, in like 2016 and 7 or that in 2016. What we find is a dramatic decrease of the sea ice cover in the Arctic happening. So that is actually changing the perspective of Arctic, how it will impact our global system. That's already we can see in the Eurasian snow cover, or even the Indian monsoon is getting impacted by that. You will be surprised to know that even Indian monsoon gets impacted by what happens to the Arctic regions. So this is something actually will have a global impact. Again, if you look at the using the GRACE, which is again a gravity measurement using the space-based technique, the GRACE observations suggest again that there's been a continuous decrease or the loss of ice happening even in the Greenland region, this is in Arctic, and we lost nearly about 281 gigatons per year. Again, as I told, 1 gigaton is nothing but about 10 to the power 12 kilograms. So it's a large amount of ice being lost, and the loss is dramatically high along the coast, simply because that's the lowest part, most vulnerable part of any land, because everything just start flowing to the ocean because of the low-lying area. Now we come to the Himalayas. In Himalayan glaciers, there are about Indian Himalayas, there's about nearly 10,000 glaciers. So, but compared to the rest of the world, studying Himalaya is much more challenging, because I worked in Antarctica, I worked in Arctic, and I also worked in Himalayan glaciers. I can tell you, Himalaya provides much bigger challenge because of the terrain. The terrain in Himalaya is much more difficult to work with because of the, it's a highly vulnerable land because of the Earth, Himalaya being continuously pushing towards to the Tibetan plateau. As a result, there is a continuous upheaval of Himalayas taking place, and the land itself was originally an ocean. There is a large amount of sedimentary material which is very loose and therefore very unreliable, unsafe. So reaching to the glaciers in Himalaya is much more challenging than sometimes glaciers in Antarctica and other places. That's something you have to keep in mind. But what we find, there have been a continuous retreat of these glaciers happening. The retreat has been as low as 3 meters per year to about 40 meters per year. So it's a large things happening over there. If you look at the entire across the high mountain glaciers, since 1980s, again, this is using satellite data, partly satellite data, and also observations together. What I find, there have been a systematic decrease in the loss of mountain glaciers through time. So this is a cumulative, the red color, what we say, cumulative loss of ice in meters of water equivalent, because the loss of ice is always mentioned in terms of water equivalent, because actually that water equivalent is nothing but actually if like 1 meter ice is, or one cubic meter of ice, actually if you melt, and how much water it will be produced. That's what you call water equivalent, because that's what ultimately matters. That's what ultimately the actual real thing, because it depends on the density of the ice, because snow is density will be as low as 0.4, whereas the ice could be as close to 1. So therefore it varies from snow to ice when certain amount of ice start melting. So one thing what we have found, there has been a dramatic and systematic change happening on the ice cover, especially on the Himalayan glaciers. However, loss of ice is only one factor what's happening in Himalaya. The defrosting of Himalaya or the melting of glaciers are leading to a lot of these blue spots you can see here. They are nothing but formation of lakes. Lakes which are made by the glaciers as they start retreating as they are melting away. They form small lakes. First it forms a small port. Thereafter it becomes a bigger lake. Then it becomes a large lake. But what you have to keep in mind is that these lakes are does not have a proper. It's not a man-made lake, or it's not a proper dam lake. It is made by the land emptied by the glacier. That means the material which is left out by the glacier is very loose. So if the volume increases dramatically after some time, which cannot hold anymore, that's the time what you will find that this entire lake can burst, which is highly dangerous, like what you must have seen. For example, in case of Kedarnath temple tragedy in 2013, what happened on 17th June 2013? You must have seen there are basically two glaciers, and the Chorabari glaciers or the companion glaciers. There's a small lake here, which because of the very heavy rain, along with the what I call this increased the very unsafe what I call the lake conditions, it gave away and bringing large amount of flood directly to the Kedarnath temple and entire temple area, and large amount of life lost in that. This is one of such tragedy which can happen in many places across Himalaya, because as glaciers are melting, what you see that this again is a space picture which shows that the glacier, which is as they start retreating, they form large lakes. You can find almost every such glaciers form small lakes. Some of them are just starting to form, some of them already expanded. And if there are people living somewhere here, as this lake get expanded and they can't anymore hold the water, they can break away, what we call actually as the glacial lake outburst flood. This happens because, as I told, it is formed by a glacier which is retreating, is formed on a moraine. Moraine is nothing but the loose sedimentary material deposited by the glaciers, and since they are loose and they are not like very strong land. As the water increases, and if some calving or the breakage of large glacier takes place, then suddenly you can have this large flow coming out of it, and this can break away. So the overtopping and this related potential geohazards are very high in Himalaya. So this is one of the effects of retreating glaciers. We ourselves study one such glacier like Gepangath in Western Himalaya. It's in the Himachal Pradesh. This is a glacier. Okay, you should keep in mind the glaciers in Himalaya are different from Antarctica. The glaciers in Himalaya are covered with a large amount of dust and debris and sedimentary particles because they come from the land here. So they don't look very clean and white as you will find in Antarctica or the Arctic. But this is actually a glacier, and this ice this lake is formed by this is again using a Landsat satellite data. These are through time. The lake was only this much in 1971. This blue line. By 2014, it has become such a big, almost 20 times expansion of the volume has taken place during this particular, about less than 40 years of time period. That because there is a village downstream here, if any of this expansion further takes place, it could be hazardous, and something happen in Kedarnath can happen down there. So the monitoring of such lakes are also equally important than just monitoring the glaciers. That's why our glacier studies are always associated with the monitoring the the glacier, lake, as well as the water which is coming out of it. Now I'll give you, in coming another just less than 10 minutes, I will just try to explain what exactly we do it to understand the polar regions as well as the cryosphere. The National Center for Polar and Ocean Research, we call it as an Indian gateway to polar regions, because almost entire polar research happens only from this institute. We are the nodal agency to conduct the expedition to these regions. However, the people involved in these kind of expeditions comes across the country, from Kashmir to Kanyakumari. We have various institutions and universities participate in these expeditions, especially to Antarctica and to Arctic regions. We provide all facilities to that, and of course, it is selected based on the quality of the projects, the science, what people want to do there. And then there is a mechanism, there is a review committee to look at the quality of the proposals. And then we finally select some projects, and those project people, entire expenses are taken care by the Government of India through the National Center for Polar and Ocean Research. And you can carry out kind of research there about, summertime, especially during month of November till about February or March. That's the right window of working in Antarctica. And in Arctic, essentially, we work during the summer of Northern Hemisphere. That is mainly starting from April till September, we work here. And we also have a station. So as you must have seen, there are two stations for India in Antarctica, Maitri and Bharati. I'll tell a little more later on, explain actually what the stations look like. There's one station, Svalbard in Arctic. And then there is NCPR also has a station in Himalaya called Himans. If you look at India in Antarctica, as I said, actually India started its first expedition in 1981, and we built our first station in 1983 called Dakshin Gangotri. Because the station was built on ice shelf, the ice shelves, as I told you, are very vulnerable because of they are a floating body of ice. Therefore, we lost the station very fast. However, by 1989, we built, so Dakshin Gangotri station no longer exists. And Maitri station, which is a second our station, and which is still existing, is called, it's built on a land compared to that which was built on a ice shelf. But we have a third station called Bharati, which was built in 2012, which is one of the most modern stations in Antarctica itself. So if you look at Antarctic expedition, we have two stations. The Maitri, which has a capacity to have about 70 people during summertime and about 25 people during winter time. These are wintering over station, we call it. Wintering over station is people can work during summer, as well as some people do stay back during the winter time to look out of the station and to carry out some amount of research, because winters in Antarctica are harsh, dark, and very cold. That means because it's so dark, it's very difficult to move outside and do much research. Therefore, most of the research happens in Antarctica during summertime. Therefore, most of the scientists and researchers goes mostly during summertime, not during the winter time. And the logistics of Antarctic expeditions itself is very complex. We operate from Goa, but then we need to reach to Antarctica. So we operate also from Cape Town, from South Africa. So many people can travel till Cape Town by flight. Then people also go by ship to Antarctica, but some people also go by. There are flights operating to Antarctica these days. Early times when we used to go to Antarctica, it used to be go by ship all the way from Goa, stopping somewhere at Mauritius, then going to Antarctica. Nowadays, actually, it's very more expensive. You can imagine actually a ship traveling all the way from Goa to Cape Town will cost about 10 crores of rupees extra because of actually the fuel expenditure on a ship. Therefore, to save that, actually, what we do, actually, people travel by air, and the material, all material required for the Antarctic expedition are sent by the commercial shipping route. And then some of the people can go by flight if they want to have specific measurements, and some people go by the ship. So this is how the things look like. We have a vessel, what we call the polar thickened ice vessels, which can actually break through this ice and come. We also have flights which can land on the ice surface. Which these are all operated by commercial. We charter them, and this is done by a consortium of countries are undertaking. Russia is handling it, and then thereafter we have several land vehicles specifically used on surface of the snow surface, like large vehicles which are like snowmobiles, as well as the belted vehicles which can transport large amount of materials. If you look at the Antarctic, we are in Svalbard. This is Greenland, and Svalbard is almost very close to it. In fact, the place where we work is almost close to 80° north, in a small what I call the settlement called Neolison. There are several countries work here together because unlike other places, all the stations are all on place. Several countries, it's like we call it a science village. You can see a complete, cross section of various countries are working in polar regions in this small village. So in that, our station is called Himadri. So this provides actually facilities for about 8 people who can live there, and then but the research has to be carried outside in this cold and other conditions. And NCP also started its Himalayan research in 2015 because of the Cryosphere is considered to as one single entity which we should understand together than understanding them in compartments. So we have a station called Himansh, which is about 4,000 meters in the Lahore Spiti region. If anybody who have been to Manali or to Leh, this is actually along the Manali-Gaza route, about 100 kilometers from Manali, up in the it's close to going to the Chinese border. The station is built around 4,000 meter altitude, and which provides the facility for most of the glacier work over there. So now I'm just trying to close down actually what exactly what I've been trying to tell, as well as what India is doing. The Indian Cryosphere research, especially the polar regions, I'm just trying to put them in 3 bullets. In Antarctica, we try to look at what is exactly happening to Antarctic ice and how vulnerable are they as the climate is warming, and how they will impact the sea level. Number 2, we look at how did the climate varied in the past, what we call as a paleoclimatology. Past climate is important for understanding the future variability because they provide the insights. When a situation which was actually something similar to that could happen in the future, we know what exactly happened in the similar condition in the past, we would know how to respond to such changes, how to adapt to such changes. So understanding the past is an extremely important thing. What we do for this is actually we carry out drilling on Antarctic ice. Ice core drilling, which is actually I'm leading that particular project, actually provides a large, long ice cores which can be studied for various chemical, isotopic, and other variables, and you can use them as changes in climate variables, and as we call as a proxy records. They provide you information what happens to the climate. Then the third one, what we do in Antarctica is that we want to understand the sea ice variability across around Antarctica, as well as the carbon cycling happening on ice. We believe that carbon cycling is a typical thing which we see only on the land, like trees and plants and ocean, which has the life in it. But what we realized, the Antarctic ice, although it looked like so barren, full of life. Therefore, carbon is actually essential of a life. So the carbon cycling is found to be very, very interesting, as well as actually has a significant impact as it's warming, because as it warms, this ice is going to ultimately reach the ocean. So therefore, we should know how much carbon is or the life is existing on the ice. So that's one study we do. The Himalayas, we want to understand what is happening to the glaciers, how much is actually glaciers are melting, and this melting is uniform or regionally varying, if they're varying, why they're varying, and how it could change in the future. And understanding the glaciers are not just important for knowing how much glaciers are melting, but also much more important to know how much water they provide to the Himalayan rivers and how they could affect as they start retreating or it's getting warmer. So how much we are going to lose available water in future. Thirdly, in a point of hazards, how will the glaciers, which is actually creating a lot of lakes, will behave in future, as they start retreating more and more, you're providing, formation of several lakes. Ultimately, they could be hazardous, or they could break away, which is putting a lot of societal lives into risk. So we should understand that. In Arctic, what we are trying to understand is actually what is happening to the sea ice of Arctic and some of the glaciers of Arctic. So this is in a nutshell the kind of cryosphere or the glacier research happening in India. And a lot of this research depends hugely on the space technology, but everything cannot be done from the space, because you need to be physically there many times to actually make measurements. As many of you are, the learned experts must have told you in the last several, weeks, space technology, it provides wonders, but you also need to have a lot of ground truthing. You need to know actually how those sensors are actually, measuring what is really there on the ground. So parallel to the such possibilities using the large scale picture of this space technology, space techniques, you also should be able to take measurements on the land. So I'm going to just show one such project which we take up. Actually, we want to understand what is happening to the Antarctic ice shelf and the vulnerability. I'll just give a video of that. The project which we are carried out along with this. It was an Indo-Norwegian project, making various measurements across the Antarctic ice shelf, like radars and corings and GPS measurements and so many such measurements, geophysical measurements, to understand how much ice is actually melting, how safe or how stable these ice are, and so on. So next will be one video on that. So this has been the project was known as MAD ice. MAD ice is nothing but it was to understand the mass balance and dynamics of the ice in that particular East Antarctica. I have this one video. I'll just try to show it. It takes about less than 3 minutes. Are you able to see this? Are you able to see?
Yes, sir. Yes, sir. Yes, sir. But we are not able to hear it. Okay.
Okay.
No
So there
sound
is no
is
volume actually. Again.
I think.
Yeah, this is actually does
Okay.
not matter. Actually, we are just trying to show the actual field work we carry out on glaciers in Antarctica. How complicated, how important it is to be studying these glaciers, and it's just to give a glimpse to the youngsters, young minds, how glacier research is carried out. It's it is about several years of work. I've just put it in 3 minutes, which is not possible. So you will not get every details, but at least you will get a glimpse of what we do it. These are the kind of vehicles we use it. These are the kind of radars we use it to check whether any crevasse existing. Crevasse can be extremely dangerous actually. Therefore, you need to do know that. Yeah. Are you seeing it now?
No, now we are not seeing that video, sir. Only the screen.
I think I made a mistake. Hold on, please.
Yes, you have to retake it, the video.
Are you able to see now?
Yes, sir. Yes, sir. The video is there.
Okay. So I will not touch anything because I was just trying to play something. No, I won't do that. Basically, it just gives a glimpse of the kind of work which we do it, just so that especially youngsters get interested in the polar research.
Some verbal commentary is also good for us, sir.
Okay. Again, back to this. I think it's done. So can you see now again?
Yes, sir. Yes, sir. Slide
Yeah.
is there.
Yeah. So I think with that, actually, I'd like to stop here because I just wanted to say that thank you all for your attention, as well as I request many of the young students to go through our. We are quite active in social media. This National Center for Polar and Ocean Research are very active in Facebook, Twitter, and Instagram. So there's a continuous pictures and activities of such polar research happening into. So we keep updating it. So I just wanted to conclude here saying that actually that the melting ice as well as the what is happening to cryosphere is extremely getting vulnerable year after year, decade after decade, and the climate change is a significantly important factor in those changes. And it's important to study them. Better late than never. We already, the India has been to very later to this polar research, but I think now we are getting into serious into polar research and understanding them using both field as well as the space techniques are going to be the future of how we will better understand the changes happening in polarities. Thank you so much for your attention. Thanks to all.
Thank you, Dr. Thamban, sir, for taking us a tour to these two poles and a third pole in India also. And actually, we were aware of these two poles. So, in the name of two animals, one is penguin and one is in the North Pole, that is our polar bear. But rather than that, you took us and showed what happened there. And with your experience, and we could see you there conducting experiments, and you were the laborers, you were the researchers, and you were the engineers, and you were all in all there. All the people are doing these things, even though there is adverse situations are there. Temperature is very low, and we are searching for, with our curious mind, what is happening there. And we were not aware of this paleoclimatology, even though me also, I haven't heard that things. And today we get a lot of things, and the five spheres, especially the cryosphere, is not unexplored area for the students and teachers. You revealed that before us. And one more thing is that ISRO is having a plan with NASA, that the NISAR mission, that we haven't heard about this. The news, that is a good news from your part, and you are part of this MADICE program, and definitely our students will follow this. And we have around 40 or more than 50 now here, and some of you may get interested to become part of this kind of NCPR research, and they want to become lecturer. So we think that you will be a guide for these students. And before we are entering to these things, we have Dr. Gopinath sir, Dr. V. Gopinath sir with us, Thamban sir, Guru and Professor. I invite Gopinath sir to make a comment on this wonderful presentation of this unexplored land for the students. Welcome, sir. Gopinathan sir.
Hello, can you
Yes,
hear?
sir. Yes, sir.
So I am very happy to be with Dr. Thamban. So long back, he was my student, former student, studying the fundamentals of geology at Government College, Kasaragod. And after his BSc degree, he has moved on to Cochin University and then to National Institute of Oceanography and also Goa. And I'm very happy that he has been elevated to the highest peak where he can reach, and definitely many more years has to come for getting his contribution. I'm very happy that I was also able to make an ocean expedition for 5 days from Chennai to Cochin, covering this Bay of Bengal, then passing through Indian Ocean and coming to Arabian Ocean like that. It was only because of Thamban. So I treat him as my guru at present, and I'm learning a lot of things. And so I have got the wonderful presentation from Thamban, and he is we were in touch, and we are in touch, and always we used to interact with each other. And by this presentation, so that is your UL Space Club, UL Space Club in Calicut district, I think. So they are doing wonderful thing, and the students are very interactive, and I find that I am not taking much time to make my comment here. So it is better to have the students to interact. So there are lots of activities to be carried out in this branch, and that is starting from geology to atmosphere, and then taking to space like that. So at the penultimate day of the Space Week celebration, you have we have had a very wonderful presentation from Dr. Thamban. I wish him all success in his future endeavor, and I wish him and his family all the best. So thank you
Thank
very much
you.
for
Thank you.
making this comment here on this fine evening. And I am very much happy that I will be able to interact with the gifted children. That is to start with the subject, that is geology. If I get a chance, definitely I will be interacting with the students at a student level. And so a lot of things which has been given by Dr. Thamban, definitely it will be benefiting the future gifted children, the future scientists. Wish those members of the UL Space Club all the best. A very bright future to you all, my dear student. So
Thank
I
you. Okay, sir. Thank
okay.
you.
So
Thank
my
you,
respect
Gopinath
to
sir.
Kutti sir and other dignitaries in this platform. So very happy to be with you, sir.
Thank you, Gopinath sir. We know you are continuously supporting us joining with us for the past 3 months, and you are providing these kind of eminent scholars of India to nurture our students. That support we want from you, Gopinath sir, and from Thamban sir also, by extending our resource pool and these things. And now we are awaiting for on this the end day of this Space Week celebration. Our member of Space Club, E.K. Kutti sir. He will make his reflection on this wonderful talk. Welcome, sir.
Thank you, Shajil. Thank you, Shajil Mash. I have heard with rapt attention Dr. Thamban, and I find that inviting a person of his caliber among in the midst of our students, as Space Club students, is one of a best decision we took. Various reasons, therefore, are there, but one important thing is the contrast with space, about which Dr. Thamban spoke in the beginning. Is not there on the reality side. What I find is probably in the one of the first expeditions, Antarctic expedition, a good friend of mine, Professor Sridharan, who was the head of, who was the director of the Space Physics Laboratory, Trivandrum, he was there. I'm not sure he was in the very first one or subsequent one, and he has narrated on his return his experiences at that time to some of us. So space is also participating in cryosphere research in some way, and more than that, your department your institution is coming under Earth Sciences, Department of Earth Sciences.
Right.
The very first secretary of that Earth Sciences was P.S. Goyal, Dr. P.S. Goyal,
Right.
who was the director of
ISRO.
the ISRO Satellite Center, and he's a satellite man. So there is a very good connection there also with Arctic and space. A third one is the Indian National Center for Ocean Information Systems, INCOIS.
Right.
INCOIS was set up by Dr. K. Radhakrishnan under the leadership of Dr. A.E. Muthanayagam. Both of them, Muthanayagam went and formed the Department of Ocean Development, and Radhakrishnan set up the INCOIS under his leadership, and Radhakrishnan later became chairman of ISRO. So there is, I see a lot of, and Incois also had a lot of connections, and the ocean also. When Muthunayagam went to that ministry, he invited me few times for certain meetings, etc. And when Incois decided their location, I was there in that land, and as the work progresses, and as the institutional organizational setup began getting formed, I was a part of it in the beginning. So I find, we have a lot of connections to talk about. Anyway, this talk is, and in addition, discipline wise also, you are in cryosphere. Ours is mesosphere, stratosphere, troposphere. So you find a lot of things of that variety. Anyway, these days is the interdisciplinary research days. So anything is related to the other, and moreover, space is a thing which is unique to every science. You view from space what is happening in the earth. So that way it is very, I'm not the time is very precious now, because your talk itself covered a very nice gamut of things, and things which we have only heard but not understood. But your talk made us understand what is cryosphere, and how tough and rough it is, and India has made a presence there. Now I'm handing over this thing to the students for their question answer. And in that thing, I just want to know one thing, that how many countries are present? The present in Antarctica, what is the presence of countries? How many countries are present there actively?
Yeah, there are 44 countries. There are 44 countries from Asia, Japan, China, India. These are the three major countries from Asia, including Malaysia is now involved in science, but they don't have a station there. I'm talking about the people who have a serious research program, long-term program, or basically Japan, China, and India.
That is very good. Actually, in fact, your presence today is giving us more ideas of getting into other science areas. We should not concentrate on space alone. There are much more wider areas where space is also can also contribute in directly or indirectly later. So thank you very, very much. I don't know how to express my thanks to you. And Gobinathan sir also has been very nice with us, and he's another student is our Ganesh Raj. And we have a lot of linkages coming with persons, eminent persons like you coming and talking to our students. Thank you very much, sir. So nice of you, and we'll be in touch. Thank you.
Okay, thank you, Kuti sir and Thamban sir again. Our students are eagerly waiting for their curiosity to get some clarification from Thamban sir. And I invite Febin Firshad to handle this Q&A session today. He's our Space Club member. Welcome, Febin.
Thank you, Shijil sir. And is my voice audible and feels clear?
Yes,
yes,
you are.
Okay, first of all, a big thanks from our part. It's very energetic thing to talk and hear from many veteran scientists, and melting of ice, polar regions, and climate change. Thamban sir had went through all the topics and doubts related to the climate change, including cryospheres influence, Arctic Himalayan regions, even satellite remote sensing, and it's a big motivation for us to interact with you, sir. As Shajil sir said in the beginning, over a past about 21 weeks, the increases of the curiosity and wider the imagination in all the participants, including us. And so it's time for the long-awaited question answer session. Well, participants who were in all the 20 sessions may know we receive a lot of questions, much enthusiastic from many participants of that particular subject. And of course, we don't have a lack of questions in this session also. And it's very difficult for us to collect the questions and select it. And before beginning, participants, I think I once more notify you to switch on your cameras when we invite you to ask your questions directly, and remember to introduce yourself, since the usernames in Google Meet might be your relatives or something. And the first question is from Joy Shibu. He asked a general doubt in many of our minds, and I invite Joy to ask his questions directly. And remember to introduce yourself and switch on your cameras. Is Joy online? Okay, okay.
Sir,
Ask your question.
am I audible?
Yes, you can ask, no problem.
Sir, are there mineral deposits in Antarctica and the Arctic region?
Yes, thank you, Joe. So, yeah, there could be mineral deposit in Antarctica, because Antarctica is also a land like any other land. Like especially like if India has mineral deposits, Antarctica certainly has to have it, because we have been together once upon a time. However, as per the Antarctic Treaty System, no mineral exploration can be done in Antarctica for another. It has been almost for 50 years now. So there is as such no research takes place, because of that it's completely banned to undertake any research related to mineral exploration, because Antarctica can be used only for peaceful purpose and science. However, there is a strong mineral deposits, and especially hydrocarbons and mineral deposits in the Arctic region. As Arctic ice is melting, large parts of the sedimentary material which is below the ocean are available for exploration of oil field. There's already a lot of oil findings and hydrocarbon and natural gas findings are existing in Arctic region. So Arctic has a huge potential. Antarctica, as far as some mineral research is concerned, it is still prohibited.
Thank you.
Okay, thank you.
Thank you, sir. And next, we have one of our active members, Adidev JD, for asking his question. He asked many questions related to the synthetic aperture radar and sensors. And I invite Adidev JD.
Let me try to put here that I'm not an expert on satellites or satellite techniques. I'm only a user of those techniques. That too, I'm still a very limited user. So any such specialized questions should be, I think, maybe Professor Kuti or Dr. Kuti could be able to tell you. But other general things means yes.
Of course,
Sir,
sir.
am I audible?
Yes, go on, Adidev. You're audible.
My first question is, what is synthetic aperture radar and light detection and ranging sensors?
Okay. First of all, I can't hear you. Secondly, I think this is not the right question. I should be answering. There are certainly the space researchers experts actually may be answering that. I should not be. I think I don't want to make mistake also.
Okay.
I can't hear you also anyway.
Adidev, please.
Febin, hello.
Yes, sir.
Febin, please limit the questions within the ambit of what is presented by our speaker, Dr. Thamban today. So please limit it within that area of expertise, and don't go beyond that, because this is an area in which you get lots of people. Last 20 talks, you have almost 15 talks are by this kind of people who are handling this synthetic aperture radar and all that. Okay, let us use the time today only for this. Please limit it to within that sphere.
Of course, sir. And Adidev, you can stick up with your third question and fifth question, the last one.
Okay. My third question is, helium and ozone are triatomic molecules formed from diatomic hydrogen and oxygen respectively. It is formed also in the same way. The formation of helium is the reason for the energy in sun. And similarly, does ozone generate energy, or if so, can we use that?
Okay. Let me try to say here again that actually, as far as the cryosphere concerned, actually Antarctica is concerned, the ozone importance is different. Ozone actually is not an energy source. Actually, basically, ozone is actually the one which actually protects us from the UV radiation reaching the surface. The ozone is important for the cryospheric region only because the loss of ozone is very high in cold regions, especially in Antarctic and Arctic. Basically, because of the the cold, very cold conditions, actually the polar stratospheric clouds, actually the chemical reactions helps the ozone to be actually as oxygen and oxygen single atom, and that creates a lot of loss of ozone, and then the possibility of UV radiation reaching to these polar regions are very high. But other than that, actually, they are not exactly used for energy purpose. That's all I want to say.
Okay, sir. And now, speaking of something related to the glaciers and the general view, Mr.
Febin,
E.V. Krishnan, sir. Okay, continue.
Febin, can I ask one more question?
Yes, you may come forward.
Sir, I have a question, but maybe it will be foolishness. If so, please pardon me. Sir, we know that the water level is same everywhere on Earth, and ice is melting in large amounts. At sea level is also increasing, but still there are places where people faces shortage of water. Will the melting of ice increase the water level there, and will they can overcome their problem if we accept the coastal areas?
No, Adidev, actually, what you should understand, water is there everywhere. That does not mean that water is drinkable, isn't it? Like ocean water, people living in the coastal areas have so much of water just out in the ocean, actually, but the ocean water is not drinkable because it's very high salt content in that. So, same way, melting of ice actually brings water to the areas where there is glaciers. That means, supposing you have a large amount of melting takes place, that water actually is useful for the people around that area. For example, in Himalayas, the large amount of this, the what I call the plains, so the Ganga, Brahmaputra, and in the Indus plains, actually, a lot of the farmers will be benefited as well as they will have problem. But the water ultimately reaches to the ocean. Once it reaches ocean has a very high salt content. Any water going into that, ultimately it becomes sea. The taste would be of same sea water. So the water which is melted from Antarctica, Arctic, or Himalaya ultimately reaches to the ocean, and they become seawater. So the seawater is like at the moment we have seawater. So the situation will be same. It will not be drinkable unless something you treat them. That's all. Okay. Thank you.
Thank you, sir.
Thank you, sir. And the next question is from E.V. Krishnan, and he have asked about the general view of the glaciers, and then he have asked about the oil drills and the international laws related to it. And Mr. E.V. Krishnan, you may come forward. Is he online? Let me check. And I think he is not there. So let me ask his questions. And his first question is the general view that melting of ice at polar regions is the singular cause for rise of sea level, and has suboceanic volcanic activity any role in the sea level rise?
Okay, there are two major causes for sea level rise. One is the what you call actually that the due to the thermal expansion of seawater, the sea level is increasing. That's the single most important factor. Second one is the glacier, the melting of glaciers and ice sheet contribution. However, what you have to keep in mind, the first one is actually it is a very uniform as well as we cannot control it anyway because actually it is directly related to temperatures of the atmosphere. So there will be thermal expansion. So that is not something which actually we cannot do anything about it. Whereas the melting of the glaciers and ice sheets are very important because they actually, if their percentage reduces, they can actually make a huge difference to the future sea level changes. Next one, you tell me.
Okay, sir. And the next question from E.V. Krishnan, sir, was what is the relevant international law as to plans to drill for oil in Arctic regions by global players? Is it not environmentally suicidal?
It is environmentally hazardous, but the Arctic rules or the regulations do permit the countries surrounding it to make what I call the exploration. Unlike Antarctica has a treaty system, whereas Arctic does not have a treaty system. It is actually owned by various countries. Like the Siberian part actually is basically by Russia. Then you have the Scandinavian countries. Then you have the Canada. Then you have the US. Then you have this, all other things surrounding it, Denmark, and so on. So basically, it belongs to a country already. So part of the ocean also, because many part of the ocean actually are extended, what you call continental shelf for many of these countries. Then there is also a regulation. Actually, there is a what you call Arctic Council, which actually is a consortium of countries who has been discussing how to explore the region for because you require resources, because as the population is increasing, certainly there's going to be resources, and nobody is going to stop it. Actually, that actually you can completely stop it. Question is how environmentally viable exploration can take place. That is something actually been discussing in this kind of Arctic Council meetings, because most of such exploration do require certain kind of thresholds, as well as certain kind of regulations. That there is not a single what you call the treaty for it, unlike Antarctica. So that is a problem in Arctic. That is exactly a big problem in Arctic. It is has a highly sensitive geopolitically, because that's one of the reasons actually why China is so aggressive also in Arctic, is actually because that actually they think there is a large amount of potential of future explorations. China is expanding its activities in Arctic in a very big way because of that. So that is very clear indication that there is a huge geopolitical interest by most of the countries in Arctic ice melting. It is environmentally going to be problematic, but you cannot completely stop it anyway. It's like exploring your own country, so you cannot completely stop.
Thank you, sir. And the next question is from Archana TM, and she has asked about the forewarnings by the natural resources when these sort of problems came. And is Archana online there? Excuse me,
Sevin, you
Archana.
can ask it directly.
Okay, Srinamata. And sir, do Maitri, Himadri, and Bharati help us know the informations about these problems, and they want, if they want, and how they want them? Us.
Yeah, no. See, they are stationed for people to carry out research. They are not an automated system actually. We do have automated what you call the weather stations and other equipments in those stations, but without people actually going into the ground and making measurements, no data is ever reliable. That is exactly the problem. Even when you use space data requires ground truthing and calibration and validation. So that is a very critical. So this is important to have these stations to carry out the research. But they also have some stations, some of these research facilities. That's all.
Okay, sir. And nextly, we have Abhinav Bijar, one of our daily participants. And Abhinav, you can ask your question directly. I think Abhinav is not in the meeting. And sir, what Abhinav has asked is what are the possibilities of creating artificial reflectors for reflecting the sunlight away in the polarized belt?
Do you think there is such a possibility? Because the polar regions are not like a small giant mirror or something. It is actually one of the largest mirror you can ever have. So making something similar to that is not something going to happen, because basically then any place there will be solar radiation is required, isn't it? The life depends on solar radiation. So stopping solar radiation is not a solution. Solution is how you manage that, how your own activities don't hurt it. Because the warming actually of the Earth's surface is not directly related to just solar radiation. It is related to the increase in human activities, especially the carbon dioxide or the greenhouse gases. Because you can have a natural variability, but you can also have a man-made variability. Natural variability happens because the Earth system changing things by its own, but it has a slow pace. Means if something which happens in tens of thousands of years is different from what something happens when in 10 years. So that is exactly the difficulty actually when we are dealing with such places. So the impact of human is a much more important thing rather than just trying to look at the what you call geoengineering, something like that. Some people try to do it. That's not a solution.
Sir, and the next question is from Alansiam Sunil. He had asked about the COVID pandemic effect in the ice melting of polar regions. Most of the factories and industries are closed for a long time in this COVID pandemic era. And so, is there any decrease in ice melt in polar regions?
Okay. Okay, but the question is interesting, I would say, but the question is interesting in a different way. See, the pandemic does not have a direct impact on this cryosphere because the what you see in these areas are not directly related to what happens on a particular locality. Unlike, like for example, when we go into a city, both the pollution which we are affecting are directly related to actually the vehicles running over there. Whereas a places like Antarctic, Arctic, and Himalaya, there is absolutely no such kind of thing directly coming from the area, which is getting transported. This transportation takes sometimes months or sometimes years, and it is actually globally circulated. But the question is importance actually, the pandemic influence on the polar research is huge. I'll tell you why. This year's Antarctic expedition, most of the countries are cut down or some of them completely stopped because people are worried about how to handle the COVID patients if something happens in such kind of places. There's places like Antarctica, if you reach once, you cannot come immediately out till about several months, sometimes a year. So therefore, actually, for example, Indian Antarctic expedition for this year is cut down to the bare minimum just to take the material and fuel to run the station and just people to look after the station. There is no research happening. Like again, second example, the entire Arctic research this year has been completely stopped because people cannot travel because of the flights and all the system, and also there's an indigenous community which are vulnerable for such kind of viruses. So there is nobody is allowed to travel to those places. So the entire cryosphere research will have a serious impact because of the COVID, because we are unable to take much measurements. So this year is going to be mainly depending on satellite or remote sensing based methods. So that is something which I think it's really important. But other than that, actually, its direct impact on those areas are very limited.
Okay, sir. And I think we can end with a final question from our part. And sir, there is thousands of active and inactive satellites orbiting around the Earth now. And what are the impacts? What are the changes in the Earth's atmosphere due to launching and managing these much of artificial objects? As this was sudden increase of man-made objects in the last few
you're
decades.
asking a question to wrong person. As Kuti sir was telling actually that I'm certainly not a satellite expert or not even a space expert. You're asking a wrong question to me.
So sorry, sir. They are getting abundance of information on space. That's why they have an unknown inclination to that side. And
Right.
to avoid that, we are bringing to avoid that, we want to make them that there is science and there is no limitation. Everything is everywhere. That's why that has to be has to break from your part also, sir. That's why we bring you as an expert, sir.
I don't answer anything which I don't know. I don't
Okay,
know
sir.
that.
Okay, sir. That these kids should know that is a scientific method, sir. That's welcome. And I have one doubt, sir. I could see that you are drilling something and you are taking a block of ice from there. And what idea we get from these blocks, sir?
Okay. Thanks for the question. Actually, see Antarctica, for example, let's imagine Antarctica. Antarctic climate has been studied only last for some decades, simply because it's been remote. Accessibility has been very difficult. So the oldest available climatic information on Antarctica is about just less than 50 years. Now, any climate system, you know that actually there's a natural variability. There is a what you call the short-term variability. Any natural variability as well as the long-term variability, if you want to understand, you require a climate data which is at least about several thousands of years. Sometimes even several hundreds of thousands of years, because that's the only time actually natural cycles become into picture. So to understand that, there is no way we have actual available data there. So the only mechanism how we can get such data is through natural archives. When we say natural archive, ice is one such wonderful archive because ice is nothing but precipitation from the atmosphere. It will have its own story starting from the ice, what I call snow start forming from on the atmosphere. When it falls, because it travels through the atmosphere, because of it carries all dust, contamination, everything what is in the atmosphere. It has a story to tell. Like Nehru said, actually, every stone has a story to tell. Like every of these particles has its own story to tell. So what we do, we drill into ice, and this ice get accumulated on Antarctic surface and year after year, very nicely, like pages of a book. So pages of a book starting from 1 to 100, the 100th one actually, so the first one will be deposited like below and the 100th one will be on top. So that the one, to know the age of this one properly, and if you can study this ice properly with clever methods as well as techniques, like using, like for example, if you want to reconstruct temperature of the past time periods when there was no instrument, one is a wonderful way to do it actually, because ice being a water molecule, there's a hydrogen, 2 hydrogen atom as well as 1 oxygen atom. So water molecules will provide a mechanism to study the temperature, because the variability in this isotope within the, for example, oxygen has 3 isotopes, of which oxygen 16, oxygen 18, and oxygen 17. The variation between oxygen 16 to oxygen 18 is temperature dependent. It has been calibrated, especially for regions where like polar regions where it's directly depending on temperature. We can essentially make out the difference in this isotope composition of this oxygen isotope of this water molecule or this ice molecule will be directly depending on temperature. So you can reconstruct the temperature of the past. Similarly, there are several such possible proxy components. Like there will be sea salt deposited on this ice. The sea salt will tell a story of the sea ice which is there available. There will be dust particle. The dust particle tell a story of which from where the dust originates. Antarctica does not have any dust, any particles. It has to come from another continent. It comes from the South America, so that will tell a different story. So that's how and so on. These are the ways how we study the climate using ice.
Thank you, sir. I think this is the basis of paleoclimatology.
Right. Exactly.
Yes, sir. We don't know about that things. And one more thing is that can we see everywhere these penguins in all over these?
No. Antarctica, sometimes if you travel to Antarctica and come back, you may not find penguin. Antarctica is found penguins are found only along the coast, especially where that ocean meets what you call ice. Those are the areas you may find penguins. But if you travel by air, you may never see a penguin. And penguins are also found only a certain time period during the summertime, because by winter they come back to their warmer places. They don't stay in Antarctica. So penguins you don't find every time, but if you have been there for a couple of times, you have a chance that you must have that.
Okay. And then one more imaginative doubt is there. Then imaginary, we have the difference is that we have penguins in South Pole, and in Arctic we have the polar bear.
Right.
Why can't we make an experiment by putting a polar bear to this Antarctic region? Why can't these scientists?
Okay, it's a very interesting question, but there is no possibility of that. Actually, no international treaty system will permit to take anything to Antarctica. Anything. Like we can't even. Do you know that actually? Although we have a station there, we live there, we cannot leave even any waste there, including our own, what they call the toilet waste. We have to carry back to India. So Antarctic Treaty is very strict about bringing any alien species to there. Even by mistake from ship, actually, there is a strict regulation, environmental protocol actually. Even when ship is traveling to Antarctica, it has to be sanitized and it has to be. There's nothing, no such kind of thing should be there. So no experiment is possible because any ecosystem has its own meaning. Why Antarctica does not have polar bear itself is a big story. Why Arctic does not have penguin is a different story. So this is therefore ecological experiment cannot be done at the whims and fancies of humankind.
And one more question, sir. Who is controlling, who is monitoring these things? These consortium?
Antarctic Treaty controls the Antarctic Treaty is a consortium of all countries. Actually, they have every 2 years they have a meeting which decides actually what kind of thing can be done, what cannot be done, and how to monitor it. Monitoring is something like it's like a peer review. Like our station, for example, can be anybody can visit, any countries can visit another station. You only have to just inform. There is no permission required because Antarctica does not belong to anyone. So Indian stations, very commonly, a lot of people, such kind of delegations come from different countries. There are these environmental officers of different countries out there. We travel to other stations and so on. So there is a consolidated report made every year and that. So therefore, these regulations are in generally followed very well because Antarctica rules are very good as well as it's voluntarily followed because everyone do understand the importance of it. Because, and most importantly, Antarctic program is done mostly by the government agencies who are already responsible for certain actions. So they are legally bound by those actions. Anything we are wrong doing it, government of India will be affected or government of such country will be affected. So those rules are therefore is followed very nicely.
And one more, the last question is that you are a person from the warm land or the tropic region, and you have to travel there and you have to live there. And what physiological change you felt there while living in the deep
Yeah, very interesting question. Actually, I also thought so. Basically, okay, you have an advantage if you come from a cold region,
Yes.
but that advantage is only applicable actually for a quarter, for a short period.
Okay.
But if you're there for a longer time period, it does not make a huge difference because you get acclimatized in a week or 2 weeks time. Then the acclimatization part is the most important thing. So for any Antarctic expedition, India does, or for example, for us, we have a training in Himalaya, teaching them the basics of this, what I call the survival, basics of this rock climbing, basics of this glacier, travel and so on. Those things have been already trained for most of the people. For those who are not, like people who does not have so much of work on the outside, most of the work if it's within the station itself, like climate people or the people who are does not have to take samples or those who don't have to work in ice, they don't have to do so much of training also. But basically, some people are, they get used to it very fast. Some people are not. Because I've seen a lot of people actually, even after several years traveling to Antarctica, still they are not very comfortable living in ice. But I have been very comfortable, so I have no problem. So it may be, yeah, every person's make, I would say.
Thank you, sir, Thamban sir, for your wonderful experience sharing with us. And now we have a guest joined with us, Dr. Ajit Peter from UK. He's actually he's from Palaoclimatology, and he is also a part of. He is supporting our US Space for the past few years, and now only he could able to attend this. And he told me that one day he will come and present these things that. And he is also concerned about this climatic change and global warming. He taught a lot of things to us, and we want for some few words from our Ajit Peter sir in this occasion. Okay, Ajit Peter sir, please. Mic is muted. Mic is muted, sir. Please unmute it. No, it's still it is mute, sir.
Hello, can you hear me?
Okay, sir. Okay, sir. Please carry on.
Hello, can you hear me now?
Yes, sir. Yes, sir. But the mic is mute.
Yeah.
Okay.
Yeah. Good afternoon. Yeah. Sorry, I managed to join only at this moment, so I did not listen to the previous talks and all. So I actually don't know what was going on. Anyway, I'm very happy to join with you, and also always I'm happy to extend my cooperation at all times. Okay, so hopefully we can meet again, and I'm happy to for any projects or any webinars at any time. This morning I had a webinar and just finished only at 12 o'clock UK time. So that's why I could not come early, but definitely in the coming days, I'll be joining with you.
Thank you, sir. The discussion was from Dr. Thamban Meloth. He was a scientist from. He's a scientist from National Center for Ocean and Ocean Research and Polar Research, and he's from Kasaragod. And he was talking on this climatic change and ice melting. That was an interesting topic to you also, sir. And next we go to the the concluding session, the vote of thanks. That's I invite Varun to make his vote of thanks. And
Shajil Marsh,
yes, sir.
yes, may button for a moment. You
Yes,
know, we have to announce what is the next program next week.
Okay, sir.
So next week we are going to have a talk on radio astronomy by a guru in that area, Dr. Rajaram Nityananda. He was the director of GMRT, Giant Microwave Radio Telescope at Pune, and he is also closely known to the recent Nobel prize, you know, the astrophysics prize, you know, physics Nobel prize also. And I will make a special request to him to talk about that, his interaction and experience with those Nobel Prize winner. This is what we are planning next Saturday. Now, Dr. Ajit Peter, you are most welcome to be part of us, and we will be very happy to have you conducting a webinar at your convenience sometime. There was a discussion raised by Shajil Marsh on the Antarctica treaty. The answer was based on Antarctica treaty. Now these are all resources, rare resources which the world has got, and it needs a regulation from being poached by rogue countries. So United Nations have stepped in and made treaties and regulations of using this kind of places. This is Antarctica is the one, and the space was another. See, today is October 10, and October 10, 1967, the treaty, such a treaty, UN General Assembly resolution, not treaty, was passed on peaceful uses of outer space. I'm just mentioning this for the benefit of students to know that, you know, this kind of the role of the United Nations in those days was exceptionally effective intervention, and they did step in at the right time to see the space is not becoming a war zone. And similarly in the case of Antarctica. So this is just, I wanted to make a little mention. I mean, today the actually World Space Week ends starts on 4th, when Sputnik was launched by Russia. That is exploitation of space first time by sending an object. And 10th October 1967 is the time when the UN. So this is the 4th to 10 is the significant. Similarly, on Antarctica too, there will be a significant time, this kind of thing, of which I am not aware. Thank you very much. We had a very nice session, a long one, but very informative, knowledgeable, and exciting thing for us, the students. Thank you very much.
Thank you, Kuti sir. For Ajit Peter sir's information, I will say that this Kuti sir, E.K. Kuti sir, former director of ISRO, he is nurturing these students for the past few years, and now he's with us. That's and in name also he's Kuti is there. Along with he is also with us with this mind that the environment we are making here for these children, sir. And we are awaiting you for a webinar from your part. And you know, you are a person from environment and ecology like that, sir. A warm welcome again. Then we are going to the concluding session. That's a vote of thanks from part of our student fellow, Varun. I invite Varun to make his what of things in this.
Thank you, sir. Thank you, Sharil sir. Thank you, Kuti sir, for announcing the next webinar. Our 21st session of our webinar series has ended. So thanks to, first of all, I just want to thanks to all participants, and then to Thamban Meloth sir. Very thanks to him because it was an interesting session to handle with an important topic, very much important topic in this situation that we have to handle about this topic. So it was really interesting and informative talk. So thank you to Thamban Meloth sir. Behalf of all UL Space Club members, thank you, sir. And thanks to Gopinathan sir for attending the session. Thank you, sir. And thanks to Kuti sir for your guidance and for participating in the session. And thanks to all friends who attended the program. And
Varun, one more. We have one more guest from UK. Now he's the IGP sir. Okay.
Yes, sir. I just missed him. Sorry, sir. But I just want to thank him. Thank him in the name of all UL Space Club members and all the participants attended here. And thanks to Shejal sir for moderating the session. And special thanks to UL Space Club students coordinators Sriram, Febin, Bharat, and Abhiram, Navaneet, and Adil also for making this webinar a successful one. And thanks to all participants for attending this session. We expect all of you for the next webinar also. And I just want to recall an announcement that about the next webinar and also about our UL Space Club WhatsApp group called Cosmos. You can contact us in that numbers. So once more, thanks to all participants for attending this session and making it a wonderful one. So thanks to all.
Okay, thank you, Varun. I think you will.
Varun, what about our queues?
Sir, our queues result will be published by tomorrow.
No,